Hi, my name is Captain Hoff. For my capstone project, I designed a soccer rebounder board that can track a player's passing accuracy. I chose to make this as I am a soccer player myself, and when I would pass against the wall, it would be hard to determine how accurate and consistent my passes were. This board has a plexiglass target in the center in front of four 8-pound springs. The momentary switch is also in the center of the target. When the target is hit with enough pace and accuracy, the springs will compress, pushing the momentary switch in. When the switch is hit, the LCD screen behind the rebounder will increase the count by 1. There is also a touch sensor which, when pressed, will reset the count to 0. It is important that the LCD screen and reset are behind the board to protect it from constant impact. It also helps the user to not focus on the score as much and more on the accuracy, pace, and consistency of their passes. The LCD and touch sensor have been coded using Arduino in an LCD ITC library. To begin the process, I sketched out my design and planned the dimensions. I knew I would want to make the rebounder fairly big but still compact enough for transportation and to fit in my basement. I decided to make it around 30 by 20 by 20 inches. I also needed to decide what sensors would be best suited for this type of project. I was originally leaning toward using a motion sensor or accelerometer. The motion sensor and accelerometer would work well to detect the movement of the ball, but it probably wouldn't be as consistent at detecting if the target was actually hit, and it could mistake outside movement. Then I decided a switch would be best as it opens and closes the circuit and it would provide the most accuracy. I believe using the momentary switch was the best choice as it is very accurate, as if it is pushed in, it sends a signal to the circuit, and if it is not hit, nothing could happen. For testing purposes, I used an LED to test the connections of the wiring and if the switch was being pushed. One concern I had at the beginning was if the springs were going to be too heavy to push the circuit, but it turned out to work well as the user has to pass with enough pace to compress the springs. This helps ensure the user is practicing game-realistic passes, as too little pace on a pass will get intercepted. The light is kept in the final circuit as another indicator if the switch was pushed. After I knew the circuit was correct, I moved on to the coding the LCD screen. At first, the coding was not working, so I did some more research and realized I needed to download an Arduino library for the specific LCD screen I was using. Once I downloaded the LCD ITC Arduino library, and the code showed no errors. But unfortunately, the LCD screen was not showing anything. It turns out the potentiometer was too low and needed to be turned up. Once the potentiometer was turned up using a screwdriver, the brightness increased and the message showed on the LCD screen. To increase the durability of the project, the plexiglass target was used, as it would be unlikely it would crack from impact. Instead of using solder to connect the wires, I used solder wire connectors with heat shrink. This provided support to the fused wires to prevent breaks in the circuit. Overall, I am happy with how the rebounder turned out, and I cannot wait to use it to help improve my skills and technique.